Hello, this is a continuation from class of lesson 10-6, just touching on the parts that we didn't get to today. But before we do that, we are just going to do a quick review. So we did part of the lesson on the volume of a cylinder, and we did the first half of the lesson, which was the volume of prisms. I had to go back and look. So now we're to cylinders, and in both classes we got through part of this. We learned what the volume of a cylinder is, just like the other shapes, the prisms. This is still the volume equals the area of the base times the height, or more specifically the area of the base being pi r squared in a cylinder, because the base is a circle. But just like earlier in the day when we were learning the volume of the prisms, we're still dealing with volume equals the area of the base times the height. So let's look down here. We looked at example 3, and I'm on page 699, by the way, and we found the volume of the cylinder in class. I think we just did it verbally, but we said we would need to find the area of the base times the height, which you'll see right here. Volume equals the area of the base times the height. And of course, to find the area of the base, which is a circle, we're going to say pi r squared and then multiply by height to get our volume. So we are going to have 8 times 8, the r squared, times pi, then times the height, which is 12. And when we multiply all that together and plug it into the calculator, our answer is going to be this to a decimal to the tenths place, and this if we leave it in terms of pi. And then we looked at example B, where they gave us a cylinder with a base area of 36 pi inches squared and a height equal to twice the radius. And we did that in class, where we solved for what the radius actually was by plugging in pi r squared into the area spot. So we said pi r squared equals 36 pi inches squared, and we found out that the radius was 6. And because the radius was 6, that also told us our height, because the problem said that the height was 2r. So 2 times the radius is 12, and now we have the pieces of the puzzle to solve. We're going to solve by finding the area of the circle and then multiplying it by the height, and that will give us the volume of our cylinder. Okay, so now let's flip to page 700, and this is the last page of the lesson. I'm not sure that we'll get through it in one video, but I will try. Actually, we probably will. I'm turning the camera to see if we can get a better picture here. Let's try that. Exploring effects of changing dimensions. Sorry, I can't get this to a good spot. The radius and height of the cylinder off to the right, are multiplied by 1/2. Describe the effect on volume. Well, when we were dealing with surface area in the last few lessons, when we multiplied the dimensions by 1/2 to then find the effects on the surface area, we had to square the 1/2. But in this case, we're dealing with volume, and we're dealing with 3 dimensions. We're dealing with the inside, and this time we're going to cube whatever we did to the dimensions. So in this case, the dimensions, being the radius and the height of the cylinder, are multiplied by 1/2. So we're going to cube the 1/2 to find out what the effect on the volume would be. So let's look down here. We would multiply it by 1/2 cubed. 1 times 1 times 1 would be 1. 2 times 2 times 2 would be 8. So this is something that you do need to know in getting prepared for your test. You need to come back and review this. You need to apply it carefully in your homework. But just remember, when we're dealing with volume, whatever we do to the dimensions, we must then cube to find the effect on the volume. So if we multiply the dimensions by 1/2, we're going to multiply the volume by 1/2 cubed. All right, and looking down at example 5, we're going to look at composite 3-dimensional figures. Now, you're used to doing this, so we're simply going to be applying volume instead of surface area. So here we have a triangular prism on the bottom There's one triangle and the other triangle's at the other end, but hard to see in my picture. And then we have a cylinder sitting on top of it. Now, because we're not dealing with surface area this time, we're not going to have to worry about, where are these touching? What's not exposed to air? What do we need to add? What do we need to subtract? That's what we did when dealing with surface area. But because we're dealing with volume, we're only thinking about the inside. So we're saying how much air or water or sand would fit inside of this triangular prism, and how much air or water or sand would fit inside of this cylinder. So let's start working on that. We are missing one part of this triangular prism, and I'm going to try not to let the camera fall off while I'm doing this. So to solve for this missing piece right here, I used the Pythagorean theorem. So I said 6 squared plus 8 squared equals hypotenuse squared, and that came out to equal 10. So now we can start by using our volume equation, which is going to be volume equals the area of the base times the height. We're going to do first our triangular prism. You don't have to. You could, of course, start with the cylinder, but I'm going to start with the triangular prism. To find the area of the base of the triangular prism, I'm going to need to say 1/2 the base times the height. So base times height is 48. 1/2 of it is going to be 24. So we've got 24 times our height, which is 9. Remember, if we stood this on this triangle, that 9 really would be our height. So we've got 24 times 9, and let's look right here. Let's see, that's these numbers right here, 24 times 9, and that volume is going to be 216 meters cubed, or cubic meters. Now let's look at the cylinder. We're going to use the same formula. Volume equals the area of the base times the height. So this time our base is a circle, so we're going to need to do pi r squared. That's why we needed to solve for this 10, because we didn't have a radius or diameter here, but what we could tell is that it went from one side of the prism to the other side of the triangular prism, meaning that this hypotenuse of the triangular base was also the diameter of our cylinder. So we cut that 10 in half, it's 5. So we would say pi r squared, or pi times 25. That would be the area of the base. Then we would multiply it by the height of the cylinder, which is 5. And when we do that, we should find the volume of the cylinder right here is equal to 125 pi meters cubed. So they're leaving this in terms of pi so far in the problem. So now we've just got to add the two figures together, the cylinder and the triangular prism. We're going to look right down here on the last line. So we're adding 216 plus 125 pi, and of course when you put that in the calculator it'll take care of the pi, and our total is 608.7 meters cubed. If you need to run through these examples again, do that. Just rewind your video and spend a little bit more time on it, but I hope that helps, and you should be equipped to do tomorrow's homework. See you on Thursday.